Guys, today we're going to be taking a GSCE past question on differentiation, and it's quite complicated, but I'm going to put you through in the most easy and most explainable way possible to you. And if you have any questions, please put that in the comment section. Don't forget to subscribe. Click the subscribe button, click the like button before we continue. And also remember, I'm Chio Math and your favorite tutor here on YouTube, and I'll teach you math in the most easiest way. I'm going to break things down to whatever level you think you are. So let's get straight to solving this. Question says the curve C has equation y is equals to x raised to power 3 minus 6 raised to power 6x raised to power 2 plus 9x plus 1. That's x cubed minus 6x squared plus 9x plus 1. So we're supposed to differential function of y here, and we're to find the coordinates of the turning point of C. That is dy dx of y and the coordinates of turning point of C. So first of all, let's start with A. To find dy dx, like I said, when your y is equals to x, therefore dy dx is going to give us n x n minus 1, right? So now we have y is equal to x raised to power 3 minus 6x raised to power 2 plus 9x plus 1, right? So in that case, we know that 3 minus 1, that is n. 3 represents n, right? So 3 minus 1, and then it will be 3 times x for this particular scenario here. So we have 3x raised to power 3 minus 1 minus 2. That will be 2 minus 1. Then a 2 times 6 times x. In the same situation, that's 2 times 6x, 2 minus 1 plus the same thing here. There's an invisible 1 here. There's always an invisible 1. So if there's no 2 or number higher than 1, if you don't see any number higher than 1 there, just know that there's a 1 there. So 1 minus 1 is 0. So we have 9 times 1 x 1 minus 1. When when y is equals to a constant, the differential function of y will become 0. So here it's just 0. So furthermore, to break it down, we know that we have 3x squared minus 2 times 6, that's 12x, 2 minus 1, that's just 12x, like that. Then we have 9 times, that's 9x, that's 9, x raised to power 1 minus 1, that's x raised to power 0, and x raised to power 0 is same thing as 1. So we have this as our final answer for number 1 for the questions, the A part of the question, sorry. So now to get the second part of the question, we're going to go like B. Find the coordinates of the turning points of C. So to find the coordinates of the turning points of C, they want us to find the values, all the values of C, of x in a graph, in a linear graph. The curve, let me just draw a sketchy graph. If we have like 1 2 3, you know this is 0, we have minus 1 minus 2 minus 3, 1 2 3, we have minus 1 minus 2 minus 3. So this is y, this is x axis. We know that at each point here, at each point, x is equals to a particular value here, and x is also equals to a particular value here. So they want us to find the two values for this particular equation. So in order for us to get the coordinates of the turning point of curve C, which is from this equation, we have to differentiate it first to get our. The reason why we're differentiating it is to get our quadratic equation, so that from there we'll start solving. I've posted my video on quadratic equation and how to solve differentiation in the past. So I'm just going to go straight to it. We're not going to waste any more. In order to find the value for x, we now add 3 times 9. That's going to give us 27 up here. So next thing we're going to do now is to find two numbers that can, if we multiply them, we're going to get 27, and if we add or subtract them, we're going to get minus 12. Take note, the minus is always with the 12, not just 12 minus 12. So let's find out the factors of 27. That's going to be 1, 3, 9, 27. So what two numbers can we add or subtract to get 12? If we add 3 and 9, we're going to get 12, yes, but we want minus 12, right? So if we subtract minus 3 from minus 9, we're going to get minus 12. And if we multiply minus 3 times minus 9, we're going to get plus 27. So we have gotten our two numbers. It's going to be minus 3 and minus 9. So here we're going to just input our coefficient to x, our new coefficient is to x. So that's going to be 3x squared minus 3x minus 9x plus 9. Remember, the 27, we just used it to get this number. When we're done with that, we just throw that away. So now we're going to, it's all equals to 0. Take note of that. It's all equals to 0. So we're going to factorize now. That's the next thing we want to do. We want to factorize. So 3 goes out of the bracket, we know, because if you divide this bracket by 3, obviously we're going to end up with 3x. If we divide this bracket by 3x, obviously we're going to end up with x minus 1 in our bracket. Let me rewrite that. 3x, x minus 1 in our bracket, and if we divide this place by 9, we're going to be having x minus 1. The reason why I said x minus 1 is because minus 9 times x is going to give us minus 9x, which is what is here, and minus 9 times minus 1 here is going to give us plus 9. That is the reason why this sign had to change. It was because of the minus sign in front. Once there's a minus sign in front, the sign inside has to change, or is going to be equals to 0. So just equate the two. We're going to bring out the one in the bracket, x minus 1, and the one outside the bracket, that's 3x minus 9. So therefore all equals to 0. So in the first scenario, x minus 1 is equals to 0, and 3x is equals to 0. Scenario 3x minus 9 is equals to 0. So x minus 1 is equals to 0, therefore x is equals to 1. So, and 3x is equals to 9, meaning dividing both sides, x is equals to 3. Therefore, the turning point, the two turning points at curve C that's going to be 1 and 3. Or you can say x is equals to 1 or 3. That's our answer. So see you in my next video, and don't forget to like and subscribe. Thank you.